Number 4. The diagram below shows two methods used by Shamil to load a box of 50 kg mass onto the lorry. Calculate the work done by Shamil using method A and method B. Okay, so method A. Okay, work is force times the displacement. So the force is 300 Newton times the displacement is 3 meter, because the direction of the displacements must be the same direction as the force. So we cannot use this 1.5 meter, we must use this 3 meter. Okay, so we get how many joule of work done. And then method B, same, work is equals to force times the displacement. So the force that is used, okay, this box is 50 kg, so that means the minimum force that must be used must be equal to the weight of the box. So the weight of the box is 50 kg, the mass times the gravitational acceleration or the gravitational field strength, so we take it as 10, okay, 10 Newton per kilogram, and then times the displacement going upward 1.5 meter, so equals to how many joule. Okay, so why does Shamil prefer to use method A compared to method B? Okay, you see method A, the total amount of work done is 900 joule. This one, the total amount of work done is 750. Okay, although this one have more work, okay, more work is done, but the benefit of using this method A is that you don't have to use the bigger force. Okay, as you see here, this one, the force that you need to use is 50 times 10, that means 500 Newton. Here you have to use 500 Newton to lift the box. This one you only need 300 Newton. Okay, so this is the reason why use method A instead of method B, because method A require less force. Okay, so this is the thing, this case only need 300 Newton because some of the weight of the load is supported by the ram, okay, by this plank. This plank supports some of the weight, so the force that is needed to pull is less than the weight. You no need to use the force that is same as the weight or bigger than the weight to move the box. Okay, alright, next, number 5. Okay, during the last school holiday, Kamal and his family went to a theme park. The experience of the roller coaster ride is fun. The diagram below shows the roller coaster ridden by them. The roller coaster started at P and finished at W, where the car was stopped by hitting a bumper. Okay, at which position the roller coaster has no kinetic energy? So when it has no kinetic energy, is here. Okay, this is where it has no kinetic energy, and also here, because here is where the car was stopped. Okay, so this one here at the bumper here, it is not moving, stop already, so that means no kinetic energy. Okay, continue. Okay, based on the principle of conservation of energy, explain the amount of energy and energy changes that takes place. So the amount of energy, Okay, explain the amount of energy is that total amount of energy remain constant or remain the same. Okay, so okay, amount the energy and energy changes that takes place. So the changes in the energy is gravitational potential energy change to kinetic energy. Okay, next, differentiate the gravitational potential energy and the kinetic energy at P and T. So at P is at the highest point and T is where it is. Okay, this one is P here, highest point. So that means here the gravitational potential energy is the highest. Here T is low point, so the gravitational potential energy will be low. And then here the kinetic energy will be high because it's moving very fast here. The gravitational potential energy change into kinetic energy here. So the kinetic energy here is high. Here because it's not moving, so the kinetic energy is low. Okay, so differentiate the gravitational potential energy and the kinetic energy at P and T. So gravitational potential energy at P higher than at T, and then kinetic energy at P lower than at T. Okay, next, when the car splashes through water at T, it starts to move slowly. What is the force act on the car to slow it down? So you have water, okay, splash through water. So like what is shown here, okay, water here, okay, here got water, so that means the car will have to go through this water lah. Okay, so when go through the water will resist the movement of the car, so that means you have water resistance. Okay, so the force that act on the car is water resistance. Explain water resistance act in opposite direction as the car and convert kinetic energy to other energy. Okay,